Let's get started. Thanks everybody for joining us today. We are Thermal Energy HQ, and we're going to talk to you today about managing peak electricity demand with intelligent thermal storage. I'm going to go through a section of the document, and then Garth is going to lead us through the vast majority. Before we jump into that, a few words on who we are. I'm trying to find here we go. We'll talk about who we are, what is expanded and intelligent thermal storage, and then we will talk about our product, the Thermal Tank, as a unique way of meeting those expanded thermal storage needs in difficult operating environments. First, I would like to ask our CEO, Rob Korn-Arens, and our President, Garth Schultz, to introduce themselves.
Sure. Thanks, Oliver, and welcome, everybody. My name's Rob Korn-Arens. A little bit about my background, who I am. Started roofing it at high school on Long Island. Through college, I would work commercial roofing. My boss had me open a branch in Atlanta, Georgia in 1979 after graduating from the University of Arizona. And then he moved me to Fort Lauderdale in 1982. In 1983, I started my own company with one pickup truck and just grew it from there. Always commercial roofing and always big stores, difficult jobs. I started an air conditioning company in 1994, and then we got into solar in 2006. Today, we're the largest commercial and solar contractor in the state of Florida. We actually did a ESOP, employee stock ownership plan, January 2nd. So now we're 100% employee owned. 750 employees became owners. So super excited. And I'm an investor in Thermal Energy HQ with my partner, who you're going to hear from, is brilliant. I call him a genius. He's invented not only this PVT and the storage, but several other patents out there. But this reminds me of back in 2006 when my sons brought me a thin film amorphous technology, a solar panel that was able to be put directly onto a commercial roof without racking. And I was like, wow, this is really cool. So we were pioneers in the solar industry and roofing. And I married the solar with the roofing. And I remember one of my first roofing shows where we had an exhibit there. We were pretty one or two solar companies in the roofing space. We just attended the AHA conference in Vegas, which is the largest air conditioning show. And I look around, and it reminds me of what was going on. The storage is very, very little at the show. I mean, big show. But heat pumps are coming on, and with the heat pump manufacturers, they don't have a great thermal storage. So I'm super excited for you to listen and how our thermal storage tanks are going to be revolutionary, similar to what I saw 20 years ago with solar and rooftops. So going to be exciting presentation. Thanks for attending. And I'll turn it over to my partner, Garth, and he can give you a little bit about his background.
Okay. Thanks, Rob, and good afternoon, everyone. Thanks, Oliver, for putting together this deck, and to Claire and to the other sales and marketing guys that have worked hard to get this in front of the people that are attending that have not seen us for the first time or want to learn a little bit more about what we're doing in the thermal storage realm. My background: I'm an automotive engineer. 1984 graduate, University of Saskatchewan, moved from Canada to Michigan to get my automotive fix out in 1988, and did that steadily in some private enterprises, but usually in consultation and full vehicle buildups. So understood everything that rolled on the ground, and then made the big dive into solar renewables in 2006, 2007. A product that we call PVT, photovoltaic plus thermal, that we've kind of built the company on and did demonstration programs on and promulgated. And then along the way, in order to store thermal energies from a solar system, you needed a storage tank, and one that would work within our architecture of our system. And that's when we came up with the tank that we'll discuss today. And we've taken it in the past year, in terms of just its base design. We now have a program with a smaller module that's going to be deployed in Puerto Rico And then also we've built up on that same architecture for larger storage capacities. So we're excited to talk about how this interplays in the modern electrification of heat. And, you know, obviously there's energy recovery and things that we'll cover in here. So we look forward to a good half hour, 45 minutes of getting your brains capped up. Off to you, Oliver.
Thank you. All right, let's jump in here. So one of the first thoughts that may come to your mind is, why is a company that's called Thermal Energy HQ talking about managing peak electricity demand? When we entered this market, the thermal energy storage market, our initial thrust was to compete against the steel tank, to replace the steel tank. And there's lots of reasons why we can beat the steel tank. But what we're learning, and we're learning more every day, is that there is a bigger problem, a problem that is calling for expanded thermal storage at an almost unprecedented scale. And we want to lead you to that story and through that story today. What we are seeing out there is that peak demand is rising faster than average consumption. There are a lot of activities that help people save electricity. LED lights as opposed to the old light bulbs, energy saving measures. But despite all of those activities, the peak demand continues to rise. And that is very important for utilities, because they have to provide the infrastructure and the capacity to meet the peak demand, or they risk a blackout. Some of the drivers, and we'll go into more detail, are summer cooling peaks, cold season heating peaks, as more and more heating capacity is electrified. And so these peaks may occur in certain time windows, maybe less than 100 hours per year, or regionally even smaller windows. But as they continue to increase, even after alternative energies, even after solar installation gains, they pose a significant problem for the industry. Here are a couple of data points. The US summer peak demand has grown by 20 to 25 gigawatt since 2010. That's 20 large gas power plants. And this is just the peak demand, right? So the peak is getting taller. In California, the blue box here, the peak in that region alone has grown by 5 gigawatt. And that is despite an installation of 40 gigawatt of solar capacity. So what has happened here, solar is able to reduce the peak during the solar hours, but the new peak is now occurring after the solar capacity wanes, and new sources of power draw, such as electric vehicle charging, are emerging. And then we have a new phenomenon that was not historically present in electric peaks, which is winter peaks. As more households are moving from gas powered heating to electric heating, the peak demand on really cold winter mornings has gone up to 12 to 15 kilowatt per home. And if you multiply that by 100,000 homes, that's 400 megawatt, right? So that's, again, a massive incremental demand on those utilities that face those cold winter mornings. The utilities are obviously not sitting still. They are building, first of all, electric battery capacity to cover these short but intense bursts. Electric capacity is very expensive. They're adding it at the gigawatt level for 2025, expected increase in battery capacity of 18 gigawatt. If you recall just a moment ago, that is about the peak increase over the last 15 years. Natural gas is making a comeback. New capacity of natural gas is being brought online. And at the more granular level, we see the utility pricing schemes change, incentivizing people to shift their capacity to lower rate windows while penalizing them for drawing electricity during peak demand windows. There's also deployment of demand response programs, essentially households or businesses allowing the utility to send a signal, and that radio signal or Wi-Fi signal then triggers either a system shutdown or a system slowdown. So if you are part of such a program, your heater might turn off for a couple of hours, and that could in some situations create discomfort. What the utilities have not discovered as a major lever is the expansion of thermal storage. Jigar Shah, who is really an industry thought leader, recently published a little article, and he said basically, look into your basements. Look at these hot water heaters that are already in your basement. If you can utilize them as a strategic asset, and by extension of that, if you could increase them, you are creating a mass capacity for thermal storage. And what it really allows the individual household and through the multiplier, the utility to do is to shift the demand from the daytime peak when people need the heat to the nighttime rate. So you can charge up your thermal storage device at night with no strain on the peak, and you use it during the day when otherwise, if you were to draw it live from the grid, you would be adding to the peak. So I'm going to turn it over now to Garth, who will walk you through a couple of fundamentals of thermal storage and then describe how exactly we are going to tackle this problem.
Thank you. So where we lie as a technology at Thermal Energy headquarters is that we're sensible heat storage. So hot or cold, and our working medium is water. The other two technologies that are out there, you have latent heat storage. Probably the most predominant one that you think of is ice storage. So that's where you can go and bank extra energy in that same volume or in frozen water and then have it out later. So that's been a technology that's been around for a long time. And then you have also thermochemical heat storage as well. So you got chemical separation in order to do that. But what we're caring about here, and that works in both directions for a household and an owner, is sensible heat storage, and that's built around our tank. Other ones that we ran across were just out at the HR Expo, and you got Steffes that's out in Bismarck, North Dakota. They build a thermal brick, so they can take electricity in 1-to-1 and then convert it into heat, store it, and then take it out into the building owner's distribution system. And that's their book of business, is doing that, and take a look at utilities in order to bank that energy and put it back out. But it's only heat. Next. Calmac ice storage. They've been the prime mover and shaker in that in this market for a long time. Mark McCracken, who sold his interest out to Trane. They spent a long time building this business and understanding how to make ice in a storage vessel and taking it in and out and being able to shift loads. And there's perfect examples in New York City and then all over where this ice storage concept is utilized in order to shift loads around the building. And in addition to where they're running and making heat, they take the off side of the chiller in order to provide space heat into the building. So this is a wintertime phenomenon for this device as well. But it can only store it take out in cold energy. And then you come to us, and then if you've seen any of the videos or anything that's online, or the way that our tank comes together, it's that device in front of you that looks like a tank. It comes into pieces so it can be readily deployed. So as we discussed earlier, we're building a 350, a 500, and 700 gallon variant, and currently under tooling is a 80-gallon variant, so we can take a look at domestic hot water situations. And really, as a tank, we don't care where the energy is coming from. You got energy recovery systems, you have existing legacy boiler systems they've put into it, but part of the topic today is that you're going to use an electrification of heat device in order to move and shift that energy and store it at the proper time of day. And further on the tank, it's certified or UL listed, the materials and all that. So that was a kind of a going in to make everyone comfortable. Yes, all the material sets are within the working parameters. Thank you. In the way that we put it together here, you can see the two elements, a thermal storage tank and then an air source heat pump sitting beside it. We've set up samples of this most recently, the grill in Fort Lauderdale, Florida at Calvary Christian Academy. And then also we did a recent one in conjunction with our partners in Puerto Rico at Power Solar at one of their power sports outlets in order to demonstrate the hot water generation capabilities. Air source heat pumps work amazingly well, to generate domestic hot water in those hot environments with great COPs, and also being able to get that feedback of what's happening out of it with their controls involved. So to make this smart in terms of controls, what we have and you can pull up the next slide, Oliver, is that we have all the way from you switch on the light switch over on the left-hand side to control a device. And then as you graduate over is that what really wants to happen in order to make this seamless so that the devices that or the schemes that Oliver is relating to, where a utility might be able to utilize and turn on thermal storage, it has that capability. And then all the way to where you're looking at predictive weather through a SCADA, which is, I look at that term all the time, a supervisory control and data acquisition, but it's going to look out and the inputs from the internet. Now that you have weather forecasting, you can know what wants to happen with this device and what should I be doing in order to become best benefit to the customer, and if the utility is involved in there, best benefit to the utility. And just to mention, by the way, we have a partner group, a young fellow by the name of Josh Plasted. His company is Solera Controls, and he's located out in San Francisco or Oakland, California. And so he has a set that we utilize within these functions. And his current business out there, he works with a company called Carbon Zero Buildings, where they go and deploy, retrofit multi-tenant residential, multifamily residential housing, and they utilize those controls in order to adequately, manage, domestic hot water loads within those facilities. When to turn them off, when to generate, and to bring it all underneath an air source heat pump operation. And with this in mind, the opportunities that have been coming up, for us, start and really has generated what we're looking at today. So there's a church out in Westchester, New York, First Baptist, and they're going to be putting up a marvelous PV array there. They got 7-acre lot. Their legacy heating was an old oil boiler in the Blunderbuss 5000 that's in the basement, consumed a lot of oil at a hefty price. And so along with the conversion of that, the church is going, what else can we do? So energy efficiency wise, they're putting in windows. And then also that gave us the opportunity to, working with them to go and coordinate an idea where in 3 blocks, you can think of energy generation sitting outside the building, us storage sitting in the middle, and then a modern day approach to implementing it within the church structure. So you got generation, storage, and then distribution. And air source heat pumps, chillers, they're all in the same kind of family, is going to be generating the energies that are utilized. We store them because they're in a pretty bizarre energy market. So during summertime months, they get hit at 84 cents a kilowatt hour for 16 hours a day, 5 days a week. And the rest of the time, at 8 hours at night, they're allowed 13.5 cents. So just the logic goes, wow, if I could make hay when the energy is cheap, I want to do that, but I can't utilize it in terms of air in the building, so I got to store it. And that's where we come in. We sit in there and we plug in to provide that storage. And as you can see, typical, and we take in just background data. They had good legacy data, so you know exactly the footprint and the operational status of the building. And you see it's all about space heat in the wintertime because they're up in New York. Of course, there's that important summertime load, and what we're bringing to them in terms of with an air source heat pump is the ability to provide the whole facility with air conditioning as well. So you see that load, the little bit of line between the summer months, that's a domestic hot water load. So that's all considered a thermal load to us. We can utilize within this infrastructure their existing 2-pipe system that's throughout the building that ran the boiler loads. Now it can run not only the space heating, and in the distribution consoles that are located inside, that allows it's like a little heat pump. It's a fan coil unit, but it's a distribution console, liquid to air, and allows us as a storage capability. We don't have to go to, oh my gosh, tall, high boiler temperatures. We can manage all that thermal with them from anywhere from 90 to 120, 130 Fahrenheit, the common operating parameters of a chiller and or an air source heat pump. So those two technologies sitting on either end, generate and deliver. We sitting in the middle says, we're going to give you all the cheap energy you want in that 8-hour period. So the billings that are looking at, you can once you weed through them and you go, oh my gosh, yeah, they're at 83 cents a kilowatt hour on peak and off peak 13 cents. So once again, that decision, like when do you want to run this device in order to have best benefit? And then we sized and we looked at storage and we said we can do 8 tanks and by resolving the math, and says that's going to give you 75% total coverage of during using off-peak energy. We can go up to 12 tanks and that'll 100% satisfy them. Their domestic hot water load at that facility is pretty teeny, so they run a school in the basement, but it's a little bit of hand washing in there. So this is all about space heating, space cooling, and allowing them so that when they switch over, they're not hit with a bizarre electrical bill in comparison to what they're paying for fuel oil. So they come out, cash positive if they use storage in this model. If they don't, then they're paying the piper in order to run an electrified heat. Gives them air conditioning, but they'd have to pay a penalty if they don't adopt a storage methodology in this. And deployed, and with the intelligent controls, obviously in the wintertime months, you're just banking heat. So those are thermal storage tanks are just collecting in that 8 hours as the machinery can produce in order to satisfy the other 16 hours before the low cost energy period enters again. And then during these shoulder seasons that will, spring entering into summer, and then also summer entering into fall, and using that SCADA, you can forward look and say, I'm going to have hot days for the next couple days, or variable weather, and then you can charge and use the machinery to say, I want hot potential available for the client, I want cold potential, or maybe some of each, because in the tank array we can valve it so that you can provide both energy sets. And then of course in the summertime it's all about how much cold energy can I bank in order to make those indoor console cassettes as efficient as possible.
All right.
Move on to constraints in the built environment. Is this so the superlatives, or the thing that we bring to with the tank, is being able to, you give us a mail slot width in through a doorway, we can fit a tank in. So obviously the stories, and then Oliver has some good ones from the AHR where he's running into, and then the conundrum from the guys with the metal tanks is what happens if you run into, they got a 40-inch wide tank and a 32-inch wide door. Well, they're deconstructing, giving the guy a set of double doors in order to do that in. So you can imagine the expense and the logistics of moving in metal tanks. We had stories of move in from Carbon Zero Build out in California when they came to our booth and we sold them tanks. We got another shipment going out to them of nighttime maneuvers when they can close down a street, and so they could feather in metal tanks in through some heating and ventilation grills in order to get a building done. With us, it's walking the parts up. And and obviously, we wore the shirts. We went out into the AHR Expo with this on our back, and it attracts a lot of attention because people on the just the practicality side and be able to deploy and store a lot of energy in a space. And as simple as you think of it, it's just, this is just hot or cold water. It becomes very intelligent with the controls involved, and then with the siting of the property. So we're happy to discuss, how this happens. I think Oliver is going to play a video that kind of demonstrates all of this and kind of reiterates what we've been looking at.
All right. So I'm just going to switch over real quick here.
By the way, before we depart today, the Zach Tanners, the Hilaire, Agnama, and anyone else that's not part of our crew, I'd like to hear a little bit of story from you guys, if possible.
I'm Zach Tanner. I'm an investor. I am in the pool business. I do build water parks and university type projects, all commercial.
Okay.
I used to sell solar pool heating back in the early 80s. Sold a bunch of heat pump systems, both water source and air. And then this obviously, I heard about this company through Jim LeBate, and I know that you guys are on the right track. So I, invested some money. Hopefully, it's going to work out. I think it will. You guys are very intelligent people. So that's my background. And
if you are involved in designing or installing domestic hot water systems for commercial properties, you have most certainly run into the following problem. You would love to use a larger thermal storage tank. Not only is it needed to meet the hot water demand of the building, but it also allows you to tap into several other advantages. It helps your existing source of energy run more efficiently. It can save you money by avoiding peak rate cycles and lower demand charges for monthly maximum power usage. It also increases the margin of error if the system is not operating perfectly. But there often is one big, or should we say, small, problem. The door to the mechanical room is too small to fit a larger tank through it. As a resourceful professional, you have always found a solution, combining multiple smaller tanks into an array. That, however, has been driving cost and system complexity up. You always knew it was not ideal, but the best option under the circumstances. That is, until now. Introducing the thermal tank. Available in sizes from 350 to 700 gallons on a 60-inch diameter, with larger versions coming soon, the thermal tank is one of a kind. It is modular in its design, which allows for easy transport to the site and assembly on site, even in tight mechanical rooms or other difficult-to-access spaces. It is made of lightweight materials. No individual component of the tank weighs more than 15 pounds. Anyone can carry them, and each one easily fits through even the smallest door. The tank is among the highest performing tanks in the industry, with R values ranging from R equals 18 to R equals 22, depending on size. Even our smallest commercial tank, the 350-gallon tank, loses less than 3.8 degrees Fahrenheit over 24 hours in free convection. The thermal tank also operates differently. Water is used as a thermal battery fluid, filled into the tank once and only moving within the tank and the connection to the heat source, such as a heat pump. We recommend water as storage medium for ease of operation, but other mixes are also possible. The optimal tank temperature is between 110 to 140 degrees Fahrenheit, but higher temps up to 180 degrees Fahrenheit can also be supported. The usage water on the load side is heated via a heat exchanger and never mixes with the tank water. The tank is unpressurized and can hold 55 kilowatt hours in the 350-gallon version. The thermal tank is made entirely of non-corrosive materials. The EPP walls, TPO surrounds, and PVC liners are eco-friendly in their production, with a more favorable ecological footprint than steel tanks. No bonded materials are used, and all component materials are 100% recyclable. The various design factors result in significantly lower cost to install, lower cost for maintenance, and substantial operating savings as described above. Should the tank ever need to be moved or disposed of, then it can be disassembled just as easily as it was assembled. In more advanced use cases, the thermal tank can also support heating and cooling applications. We even had clients use a tank farm in place of a large cistern. Lack of large thermal tank options was yesterday. The thermal tank is the answer for your next larger-scale DHW system. Check out more details on thermalenergyhq.com or contact us at info@thermalenergyhq.com.
All right. So let me stop sharing. And I'm going to go back to the presentation. Sure, back to you.
Okay, so we're set up, and our alliteration of the day is where we perform one highly insulative, sitting out in our parking lot or in free convection. The tank loses about 2 degrees C per day, so very low losses. Practicality, so if you can move this in and get it sited, you've taken headache, away from contractors, installers, and people that, they say can't do it because, yes, we can, because we can. And then price, the constituent components that we have gives us, best in market value, even beyond, being able to move it into a space in the way that it performs thermally. And then, as the little video alluded to, if it met an end of life circumstance, it can all go back to its constituent components. And what we've done with a partner group in Puerto Rico called Power Solar, we've signed an agreement where they're going to use a small little, mini monoblock, something you can plug into the wall, 900 watts, but it produces 3.5 kilowatt output nominally in order to do domestic hot water. So this gives them the ability, they're a solar installer that does many installations per month, and this becomes another offering in their system because it's a take up for the PV that's being produced, and then also gives them a leg up on their competition to offer the client something that they didn't have. And if rightfully placed, the heat pump, because it's drawing, the hot air or energy from the air, its output is cool air. So if you put it in the right space, it provides air conditioning. And because of the consistent environmental, always kind of the same temperature in Puerto Rico and the Caribbean and other places, this becomes a 2-for win in terms of the business case. You're generating domestic hot water, but you're also participating back into the space cooling energies that otherwise you'd have to pay that rate again in order to resolve that energy.
All right. And that takes us to the end of our prepared remarks. And we'd like to open the floor for any questions or comments, thoughts, for those of you who've seen it maybe for the first time. Does anybody have a question?
Can I jump in?
Please.
Yeah. Hi, everyone. Nathaniel, thank you for inviting me here. My name is Hilaire Nyama. A colleague of mine sent me the link, and here I am listening to very interesting technology. I am a Togolese. I am from Togo. I live in the UK. I am the elected representative of the Togolese diaspora in the UK. Work very closely with the Ministry of Foreign Affairs in Togo. And part of my job is to explore opportunities we can then take to Togo, either within the Togolese community or the wider investor business community in the UK and elsewhere, looking at how we can support the development of Togo. Something interesting about this presentation is that I think that can work with Togo is developing an industrial park now with the electricity, water, and then everything being supplied by the government of Togo to the park. So which is a partnership between the Togo government and Arise. They do build industrial parks all over Africa. And the energy coming from Togo water and all those things coming from Togo government, I think this can be an opportunity then to see whether this can be provided to the park or explore opportunities with Togo government and see this can be adopted. That's so far what I understood about the presentation. I may be wrong, but again, Togo is a hot climate, is quite warm there. And what Gaf just explained about using this as a heat, but also as a cooling system can also work with countries like Togo and other countries in West Africa, which I know the best. And so thank you very much for the presentation.
Yeah, thank you for your comments. We'd be very open to discussing that with you in more detail. Our approach is always to understand the situation on site, what is needed in terms of heating needs, domestic hot water needs, cooling needs, and how can the technology be deployed or work with technologies that are already in place in the local environment.
Thank you.
Thank you for your comments. Other questions? Who else has a question or a comment?
Yes, good afternoon. Can you hear me clearly?
Yes, we can hear you.
Okay, my name is Nathaniel Aladeo Bonito Hicks, and I'm from Nassau, Bahamas. And Hilaire is my business partner in Africa. And I invited him on to the meeting today so that he can see the opportunities that is available for Africa. And my main question is, and I think you already answered it, but I am still going to ask it. I get that the proprietary knowledge of the system is American based, but is the components for the manufacturing of these products, is it also American based, or do we have to depend on China for components to put these products together? Because the reason why I'm asking is because of the trade wars between America and China. I want to make sure once we start mass production and so forth, there won't be no disruption on us providing the products. Because like you can see, I already have my affiliations in Africa. I also have my affiliations throughout this Caribbean region, and I want to make sure once I put my name and my reputation behind the product, I will make sure that we can supply the mass orders for it. Because trust me, everybody who I've introduced this product to, they love it, and I see the success of it. And thank you for the opportunity to be part of this meeting.
So I can speak a little bit to that in terms of our thermal storage tank. Yeah, all 100% U.S. made. So everything is designed to, in Michigan, and my supply sources, in terms of foams and TPOs and liners, that's all around the Michigan and around the automotive belt. To speak to, supply chain for the air source heat pumps and those motivational. Yes, there are dedicated manufacturers in the U.S. that make all their own product, but predominantly, it's the chain for that's a Southeast Asia. So there's Malaysia involved. There's also heat pumps available from India that spread out from the China from China proper. So that supply, we always curiously and look at it. And there's also a supply base over in Poland as well, over in the EU. So it's coming to where you can realize within your specific market what's best suited for that heat pump or for that generation mechanism.
All right. One additional comment maybe on the scalability of supply. If you think about steel tanks in this magnitude, 350, 500, 700 gallon, the time the lead time for production of significant volumes of these steel tanks is significant. You will not be able to get them in a fast turnaround. Because of as Rob pointed out, the genius of Garth, he has essentially taken relative commodity materials and has turned them into a high value product. So we can work with the manufacturers of those components to scale up the production much faster than a steel tank manufacturer could do.
For example, the outer hoop material that contains the fluid pressure, that's common roofing material. So that's a 30-year kind of UV resistant product. The foam that's inside expanded polypropylene, that comes from the automotive community, industrial community. And if you've put on a bike helmet or you've taken a bumper off a car, that material is in the front side. So common, lots of production capabilities, worldwide for that. And then the PVC liner that comes from the geotech membrane industry. Ours is suited for higher temperatures, but all that construction and all that wherewithal, resides in the U.S. or in many industrialized countries.
All right. Thank you for your question, Nathaniel. Do we have other questions? All right.
Guest question wins a tank. We got little model tanks that Claire is going to drill you on, and we'll get them out to you guys. They're a model so you can see exactly how this thing goes together, and so that you can, sit there and think, where do I apply? How does it go? Till you get one of these things in your hand, quite honestly, unless we build a big one, you can take a little model, and then you can see. I can see how it can transport. I can see it where it can site. I can see how it can deploy, and I can see its benefit. So that is going to, it's a two-way street. We're going to take your name and number, and we're going to pester you, but at the same time, you'll get what the actual core element is. So.
Hey, Garth, this is Jim LeBate. Thanks
Yes.
for the
Hey, Jim.
looking forward. What do you see as the most opportune industries for you guys to move this into?
Well, I'm going to let Claire. You're gonna tell them along with Oliver. So we'll put Claire. We'll put Bill McGee on the floor here to tell us where they're delving into in order to seek sales.
Thank you.
One of you two.
Yep. I'd say right now, like schools, multifamily apartments, universities, hospitals are kind of some of the main.
Yeah. Essentially, any industry, Jim, where you have high hot water usage, our core strength is the domestic hot water. As Garth illustrated earlier, if you have enough space that you can expand to a tank farm, then it really doesn't matter which industry you go into. Laundromats, breweries, even district heating, which is not yet as popular in the United States, but the next generation of district heating will use ambient temperature water loops that run through the community, and a local heat pump at the building will then bring that ambient temperature up to use temperature. So every building is going to need a heat pump and a storage device. That puts us into the residential space. We are working in Westchester County with an organization called Sustainable Westchester. They are recruiting contractors and are promoting solutions to their local residents. And we are deploying a residential offer there to move both the domestic hot water and the space heating of those homes to our product. So even the residential market can benefit from this solution. And obviously, as Garth illustrated, in Puerto Rico, where you have a consistently warm climate, utilizing the small tanks for domestic hot water is going to be a big market. In that market, you don't have space heating needs, so you don't need a big tank. You can do it with a small 80-gallon tank.
Gotcha. So I saw on the installation you just did out of Calvary Chapel, the payback's like 2 years. Is that where do you see the the quickest payback time where it's, sort of the low hanging fruit for you? What businesses is that a good example of it, the Calvary one?
Yeah,
It is.
yeah, go ahead. Carl.
You have low cost, relatively low cost electricity in that site, and you had high cost propane that they're operating off of. Now, if you tried to say I'm just going to do an immersion electric and do this, it'd be greater than the propane. But operating through an air source heat pump give them great opportunities to trim that hot water bill significantly. So you're going to look for those right markets. It's always energy dependent, or time of use or demand charge driven. And that the materials presented today, we kind of went over the time of use and maybe in demand charge where you're getting really hit with high costs if you want to move over to electrification of heat, but also in the cooling realm too. So you have a chiller that's running, and I don't want to run it when the electricity is expensive. And as these markets start to go time of use where you got off peak and you got on peak, you're going to go, what can I do to make me, the off peak, give me that off peak pricing. And then those, like Hilaire, you're out in there, you might have a microgrid. A microgrid operates more efficiently where you can go and bank energy when it's needed and when it's most appropriate. Your microgrid might consist of a lot of PV, wind applications, and then when that energy is present, you want to store it so that you can utilize it later on. So those opportunities are around on the heating and cooling side.
So I have a contact that they do a lot of manufactured home parks, new ones.
Yep.
Is that something you could go in at the ground floor with that would make sense?
Yep. You can certainly help them achieve, if if they're going to use an electrified heating source or cooling source, air source heat pumps, then that gives them that advantage in the coming years when those time of use peak or demands. And then as kind of Oliver pointed out, Jigger Shaw going, when can we can turn these devices on so that it gives grid relief when most needed. So those are things that you can plan for and implement today, for coming for today's reality and the more stringent reality that's going to come in the next few years.
Right.
Gotcha. Okay.
If you go through the economic stack, you first have sort of the organic dynamic of what is the market price for the energy that they're using today, or the energy for electricity if they're moving to electricity. Then you have the federal incentive component. Our product remains eligible for the ITC federal tax credit at 30%, plus for the tank side, an additional 10% for domestic content. That is not the case for most solar or wind technologies, but thermal storage does remain subject to those credits. And then if you are in a geography that is really pushing decarbonization, New York, California, most of the New England states, you have additional state incentive programs, or you may even have utility incentive programs, right? So our friends in California who keep buying our tanks, they are masters at that stacking of the incentives, and that obviously changes your payback equation dramatically.
Okay, thank you, Oliver. That brought a lot into focus. Appreciate it.
You're welcome.
I'll tee up an introduction for you guys to those folks.
Much
Thank you.
appreciated. We appreciate your support. All right, I think Garth has done a masterful job. Please go ahead, Nathaniel. Go ahead.
Now, I'm just new to this system and so forth, right? I've been doing my research on the solar systems and the storage capacity, and I hear you talking about the 50 kilowatt generations and so forth. Could you explain to me in layman's terms the storage capacity, please?
Storage capacity. So you think of that body of water that you have within that tank that when you raise its potential or lower its potential, hot or cold, based on that fluid volume, its mass, and it has a specific heat, you can, if you have a device that's putting in, 10 kilowatts of power, then in that hour, in an hour time, it's going to store 10 kilowatt hours. And within our smaller 350 gallon tank, if you're generating domestic hot water, that would, if you went to a potential where your incoming fluid that you want to go, your cold fluid coming in, and then your exit temperature, that delta T is what describes, the energy storage potential. And at 35 degrees centigrade, Celsius, in that tank, that's like 54 kilowatt hours of stored energy. And you got to take it in, move it out and use it, fluidically, heating, cooling, but that's the kind of the storage potential. So it's built on temperature differential that's stored in the tank.
Yes.
And
So my main question I really want to know about, because with solar, especially if you're on a off-grid system, you collect the energy through the daytime and then use it through the nighttime, and then especially during storm time, especially during a hurricane time and so forth, you would like to have storage capacity that can last anywhere from a week to a month, without any backup energy or so forth. So I want to know, can I hook up the batteries to that to store energy for a longer period of time? So when the temperature goes down or so forth, I will still have electricity for a longer period of time.
we're not a chemical storage device. We're thermal. So if you're gonna bank it, and let's say you had that PV system running, that you'd be running a device to cool a house or heat water, that's where that storage potential would lie. Now, is it a week? Depends on the, we're mainly on the diurnal or the, daily storage relevancy of this, but it allows you to most efficiently operate your PV system, because if you run out of, I've got no loads and the sun's out, what am I going to do with, this energy that's coming? And your battery banks are full. You can store it for the use that probably the solar system is next to, the building or the house or the school or the hospital, that you can utilize that thermal energy in. And then it gives you that great capability of, enabling your solar system to run most effectively for you and your client.
Okay, and one more question. Say I initially set up a system. Let's go with the smallest one. How long will it take for me before I can actually use the energy out of it? Because I know when you're setting up a solar system, it takes anywhere between 24 to 48 hours for the capacity to build up for usage.
Yeah.
So how long do you think it will take for it to build up for usage?
We just did this in Puerto Rico, and Lewis, you can weigh in, but in 3 hours from when the firing gun to set the system up, we're, to assemble the system, and then we went away for a training session, came back in 3 hours. You had domestic hot water temperatures out of the air source heat pump and banked. 350-gallon tank, 3.5 ton heat pump assembly. So it's very quick.
I think Nathaniel froze up the
We
connection.
excited him so much, he's frozen in space.
All right. Great, Garth, thank you for those additional explanations. We'll take one more question if there is one more. Going once, twice. Thank you everyone for joining us today. Thank you, Garth, for your explanations. And if you have any additional questions, if you'd like materials, marketing materials, we have more videos. Check out our website or contact us at info@thermalenergyhq.com, and we will be more than happy to follow up with you. Thanks, everybody.
Thank you.
Bye. Thank you. Hi, Nathaniel.